Hello, everyone. My name is Tejas. I'm Principal Program Manager for SQL Server Product Group. I lead the strategy for SQL Server on Linux and Linux containers at Microsoft. Welcome to SQL Pass 2020. Today, I'm going to talk about SQL Server on Linux in Azure ecosystem. Before I go too far, I just on behalf of Pass, I want to just highlight some basic housekeeping stuff. Please do explore everything that Pass has to offer, and your feedback is extremely important. So please provide session evaluation and feedback as soon as you can. I would really appreciate it. Now, to begin with, on the agenda today, I have SQL Server on Linux introduction and some of the improvement themes for SQL Server 2019. I'm going to talk about SQL Server on Linux images in Azure Marketplace, some performance tuning guidance, and enabling high availability for SQL Server on Linux, especially on Azure ecosystem. And I'm going to keep the agenda tight because I have a lot to talk about in each of these topics. So SQL Server on Linux was introduced in year 2017 with SQL Server 2017, obviously. It is available for production support on Red Hat Enterprise Linux, SUSE Enterprise Linux, and Ubuntu. You can deploy it in container form on Red Hat OpenShift and Kubernetes platform, apart from basic container deployment as well. And of course, it is supported on Windows platform. When we introduced SQL Server on Linux, we ensured that we do provide some native Linux experiences. So, for example, the installation for SQL Server on Linux is based on the packages, which is the native form of installation for Linux. And the most important thing, though, is while we provide SQL Server on Linux and containers, we maintain database compatibility across all the different platforms. So today you can take a backup of the database which is running on Windows platform, deploy it on Linux platform, or even container running on OpenShift or Kubernetes environment, and run the same query and get the same results and even similar performance, provided all the resources are equivalent. The way we did it is using a platform abstraction layer called SQL Pod, and you can read all about it in various blogs and the project drawbridge at Microsoft research site. Now, I just want to introduce SQL Server 2019 briefly. So SQL Server 2019 focuses on some of the modern data challenges. It introduces a functionality called Polybase for heterogeneous data access and virtualized access to data estate across the system, including access to HDFS data, even with native HDFS implementation as well. SQL Server 2019 introduces integration with Java as a language, along with R and Python support, which was introduced in SQL Server 2016 and 17. The intelligent query processing umbrella has grown, and there are additional improvements so that if you just start using SQL Server 2019 with the latest database compatibility, you should get better performance and much higher throughput. And of course, we also introduced accelerated database recovery, which helps with both rollback and the database recovery scenario. All the while, we have also ensured that we access or we support more and more platform and the operating system, because our users are also diverse, and we recognize that as a fact. So let's focus upon SQL Server 2019 on Linux, and few things that which we specifically did in SQL Server 2019. So SQL Server, when we introduced SQL Server 2017, we did have some gap in functionality, which were some of the functionality which was available on SQL Server on Windows was not available on Linux, and we have tried to fill the gap as much as we can. So we have essentially focused upon most high-use scenarios, such as replication and change data capture, or CDC, the machine learning integration with R and Python, and language extensibility with Java is also available with SQL Server 2019 on Linux. The poly-based support has also been introduced with SQL Server 2019 on Linux. There are some additional improvement in terms of the hardware enablement, such as enabling persistent memory support, which is also in SQL Server 2019 on Linux. All the while, we have also added support for additional distribution and versions, and including the Red Hat Enterprise Linux Container Image, or the UBI Container Image, and SQL Server 2019 container images run with non-root privileges for additional security. Okay. So SQL Server 2019 adds support for additional versions or major versions of the distributions that we already support. On Azure as a platform, we have made sure that we have added images such as SQL Server 2019 on Ubuntu 18.04 along with 16.04, and SQL Server 2019 on RHEL 8 along with RHEL 7.04, to make sure that you can deploy SQL Server on Linux in Azure as a platform very, very quickly. Now, why is this important? So having images or pre-configured, pre-built images in Azure provides you with flexibility and agility of deployment, which is unparalleled to anything else. Just to give you an example, just for the testing purposes, I deployed a 4-core 32 GB VM with SQL Server 2019 on RHEL 8. The size I chose was standard E4v3, and the image I chose was SQL Server 2019 on RHEL 8 VM image. And as we can see, the entire VM was deployed in less than 2.5 minutes. So as you can imagine, in under 2.5 minutes, you had a 4-core 32 GB RAM machine running with SQL Server 2019 on Red Hat Enterprise Linux 8.0. Another good alternative for quick installation for SQL Server on Linux remains shell scripts, or the use of shell scripts. For example, in this example, shell scripts, I am configuring the repositories and running the installation steps. Additionally, I'm also doing certain post-configuration installation, such as configuring the appropriate environment variable for SQL Server tools as well, and necessary the firewall configuration. And this kind of shell script can be extremely efficient for SQL Server deployment in Linux ecosystem. For example, I executed this particular shell script on a new Ubuntu installation in Azure. And if you can see from the start time being 11:59:06 and the end time for the installation being the 12 o'clock, basically in just over a minute, I was able to install SQL Server package and do necessary custom configuration, including installation of SQL Server tools. Now, you also have to remember that this does not include the deployment of the VM itself. And considering you can get quicker deployment with the marketplace images, I would still highly recommend use of the marketplace images for your deployment. But I just wanted to provide you the second alternative in case you are interested in doing custom configuration and custom deployments. Once you have decided on the SQL Server version and the operating system version, which basically gives you the image that you want to work with, the next step in the decision-making process is, what are the resources I need to deploy this image? Typically, that goes with the combination of cores and memory. And what we did is we analyzed the most commonly used SQL Server deployment in Azure ecosystem to understand what images are most commonly used for SQL Server deployment. And we basically sort of segregated them in 3 T-shirt sizes. The 128 core and higher are large T-shirt size. 64 core and more are the medium T-shirt size, and 32 cores and less are essentially small T-shirt size. And we have listed out some of the most popular SQL VM sizes which are used to host SQL Server in Azure ecosystem today. Now, it's important for you to take note of this is that the reason why most of this image or rather the VM sizes are popular is because they provide you with great core to memory ratio. Basically, SQL Server being memory hungry application, you typically want a high amount of memory per core for better processing, and the number of Iops also matters. And this VM sizes seem to be very, very popular when deploying SQL Server in Azure ecosystem, as they seem to provide the most commonly required infrastructure for your workloads. Next topic is, now that you have determined the SQL Server version, the operating system, and the VM size, what is it that you want to focus upon next? The next topic of configuration is storage. And the first thing you would want to make sure is that you take into account the required Iops, because along with memory, SQL Server or any database management system is typically very heavy on the storage. And you would want to make sure that the configuration that you have selected works best for your memory and storage requirements. Now, in case of Azure, you have to make sure that you know that the VM sizes, each VM sizes have their own Iops limits, and each of the managed disks that you elect to attach with the VMs, they have their own Iops limits. So, for example, if I go back, the E6432DS v4, which is one of the more common deployment VM size, has Iops limit of 80,000, including cached and uncached. So this is what you want to account for, that when you are considering your storage configuration, you want to make sure that your VM also has appropriate Iops limit at the VM level, and you attach appropriate amount of storage to get the required Iops for your workload. And the thing to understand is that each managed disk can have their own Iops limits. So sometimes you want to attach multiple managed disks to get the required Iops. So next thing to consider is, now that you have designed your system with the required Iops, and you have elected the number of disks with required Iops as well. So for example, P30 drive has 5,000 Iops, and if you need, let's say 30,000 Iops, you would need at least 6 of these drives to make sure that you get the required Iops. Great. Now that you have attached multiple managed disks to get the required Iops, and the VM also has appropriate number of Iops, the next thing you would want to do, make sure to get to ensure that the storage can handle, or the storage which is hosting your database files can handle required Iops, is to ensure you have a RAID configuration. Now, in the case of Windows, you would probably use something like storage pool. In case you were doing this on premises, you would want to use something like a hardware RAID. But considering the hardware RAIDs are not available on Azure today, you can use software RAID to essentially stripe your storage across the number of disks to get your required Iops. And you can use utilities such as MDADM to configure the software RAID in case of Linux over multiple managed disks to get the required Iops. Now, another thing that you would want to make sure is, when you are configuring your software RAID, you want to ensure that the stripes and number of devices and block size, everything is appropriately aligned. Now, typically as database administrator, this is where you would want a good storage administrator or the system administrator to chime in to help you with this configuration. I just wanted to give an example of how you can configure software RAID to support the required IOPS. For example, in this case, for the log file, I'm using 4 drives, our number of devices being 4, and it is striped in the 64K chunks, so to get the maximum amount of throughput. When it comes to data, for example, I'm using 9 devices and 8K stripes in the RAID 5 configuration to get the most throughput required. And for the temp DB configuration, I'm using RAID 10 configuration with 64K chunks and 6 RAID devices. And when I mentioned the appropriate alignment of the blocks and the stripes, for example, in the case of 10 DB, you have 6 devices or 6 drives configured in RAID, which means you have 3 bits worth of data, and the S unit, for example, in this case, and the block size basically say that 16 into 4K, which is basically 64K stripes. So this is how you would want to check on the alignment. Again, you would want to use the storage administrator to ensure that you have the appropriate alignment of the stripes and the data so that to maximize your throughput. But what I wanted to highlight was that once you have configured appropriate number of managed disks to get the required IOPS, you would want to use something like software RAID and MDADM to stripe it accordingly to get the managed disk, which can host your data and log files. So now that we have configured the storage component on the hardware side of things, you have attached a disk, you have created appropriate RAID configuration on top of it, and you have attached it to the VM itself. What would you do next? For the next, you want to choose the right file system to host your database files. And SQL Server on Linux supports 2 file systems in the Linux environment with our XFS and ext4 file system. We are now categorically stating that we prefer XFS file system due to the continued amount of improvement and investment into the XFS file system that we see. We have been working with all our Linux partners, Red Hat, SUSE, and Canonical, and XFS as a file system seems to be seeing the most amount of investment in terms of improvement. So we are recommending XFS as your go-to file system. Now, what would you do next? Now, the next step to do is once you have basically formatted the drive with XFS file system, you want to ensure that SQL Server is configured to use this XFS file system appropriately. Now, I'm not going to go into technical details about the FUA bit. FUA is a functionality which basically is used by SQL Server to efficiently flush the IOs independently so that we can implement the vault protocol or write ahead logging protocol, giving you the stability and recovery, and ensure that you can your database can recover from crash recovery just fine, while giving you the highest amount of performance. Now, the blog that I have mentioned over here has significant details. What I would say is that when we started using SQL Server on Linux, we realized that Linux as an operating system does not have FUA support in the user mode. We work with our partners in Red Hat and SUSE Linux distribution to get the FUA support appropriately implemented in user mode. This support is available in Red Hat Enterprise Linux 8.x and /12 SP5 onwards. We are working with our Canonical partner to get this support in Ubuntu 18.04. And we do recommend that you use one of this version of the Linux distribution. You can use the earlier version, but if you use this version, which has the appropriate FUA support, you can get much higher I/O throughput with far lesser performance impact. And and the way to configure this FUA correctly is if you are using XFS file system, and if the device or the managed disks which support FUA, which in the case of Azure they do, and if you are running a system which is patched, which is RHEL 8X/12SP5, and you went to 1804 onwards soon enough, then you can use this TraceX 3979 and appropriate MS SQL configuration to get the appropriate throughput. There is, if you are using any of the earlier version, there is an alternative configuration you can use, which is a part of this PowerPoint. So you can, when you download this PowerPoint, you will see it in the notes section. But the reason why I'm saying stressing about this FUA support is because in our performance validation, we have noticed somewhere between 30 to 40% performance improvement if you use SQL Server with FUA capable system on Linux. So we highly recommend and encourage you to use SQL, the RHEL 8X/12SP5 and more FUA supported Linux distribution and the configuration. All right, so now we have talked about all the storage configuration, including the physical configuration and SQL Server configuration. What next in terms of storage? Now, one more thing that you should do when you are mounting the storage is, or let me put it this way, when you are mounting the storage automatically in case of Linux, the way you do it is you essentially make an entry in this file etc fs tab, and you give appropriate parameters for Linux to load this correctly at the boot time. We also recommend one more thing. When you are mounting this file system or giving the appropriate parameters in fstab file, you should use the no A time option. This is equivalent of or approximating a configuration of NTFS disable last access update in case of Windows. What it does is it disables the timestamp keeping for file modification. So, and what we have noticed in our performance validation is that considering SQL Server is updating the data and log files all the time, there is a huge performance impact in maintaining the last access time all the time. So the recommendation is for you to use no A time option in the fstab file so that we can reduce the performance impact of this particular issue. What next? So in terms of storage, there is one more thing I just want to mention. Today, we do not have systems or VMs which have PMEM or persistent memory enabled. In future, though, it's likely that you will have VMs which will have persistent memory support. One of the things that you should do when you are using persistent memory and you are mounting the persistent memory as file, you should make sure that you use the extent size as 2 megabytes. Because unless you use the extent size appropriately, the performance improvement you would see with features such as hybrid buffer pool or enlightened I/O, you won't see the impact of the performance improvement otherwise. So again, if you are using persistent memory and mounting it as storage, you should mount it with appropriate extent size to ensure that features such as hybrid buffer pool and enlightened I/O for database files for SQL Server on Linux can kick in and provide you with performance improvement. All right. So we have talked about the VMs. We have talked about the storage configuration, including formatting and mounting the storage correctly. Now, are there any additional operating system configurations for us to consider? And indeed, there are. We have our SQL Server performance team has been doing quite a few performance validation with SQL Server on Linux across many versions. And we have documented quite a few kernel configurations in our best practices guide. You should see the link over here. Now, there are quite a few of these kernel parameters mentioned over here, and I'm not going to describe them individually. There is a lot of text over here. What I will say is, as we have been doing performance validation across many of these scenarios, we have learned that each of these parameters, when configured correctly, can give you quite a performance boost. You have to remember, Linux is a great open source and highly configurable operating system, but that also means that you should know how to configure it and tune it correctly to get the best performance out of it. And we have been tuning quite a few parameters in terms of the kernel parameters mentioned over here to get the best performance for SQL Server on Linux ecosystem. So, for example, the swappiness parameter helps reduce the impact of paging for SQL Server. The VM dirty parameter, and there are a set of these parameters, help lower the impact of SQL Server on file system cache to reduce the performance impact. Then there are a set of parameters under the kernel.scheduler, and they help optimize the completely fair scheduling algorithm for SQL Server workload so that it minimizes impact on IPC or interprocess communication, and it improves the throughput by improving the network and storage processing for SQL Server workload. And so there are quite a few of these parameters, and you should know about this on how to configure this. They are all documented on Performance Best Practices Guide. Now, the good thing about this is, though, you can configure all these parameters very, very quickly and efficiently using a process called TuneD. It is available on Ubuntu 18.04, RHEL 7 and RHEL 8 and /12. You may have to install it on appropriate distribution if it is not default. It is available by default in Red Hat Enterprise Linux. And the proposed kernel tuning parameters with appropriate configuration file is documented on the best practices guide as well. Okay, so now that we have talked about the kernel tuning parameters, are there any additional parameters that we should consider? And indeed there are. There is a parameter called memory.memoryLimitMB that you can configure using MS SQL Conf. There is a reason why you should know about this parameter. Now, historically, when Linux as an operating system runs out of memory, it turns towards the highest resource consuming process, which typically will be SQL Server on any machine, and it tries to basically kill the process. And colloquially, this process is known as killer or out of memory killer process. Now, by default, to reduce the impact on the operating system, SQL Server uses only 80% of the available physical memory. Now, that can be a consideration if you are using a high-end memory system machine. For example, if you are using a system with 1 terabyte RAM or 4 terabyte, or let's say 1 terabyte RAM, then if you you are essentially not using 200 GB that could have been used by SQL Server, and it is left for operating system. Now, you should really carefully consider your operating system and make sure that you leave appropriate amount of memory, but you could potentially, let's say, increase the memory limit from 800 GB to say 900 GB or 850 GB or 925 GB, according to the memory usage for the rest of the Linux operating system hosting SQL Server without running out of memory. And you can configure that option using this memory limit option, next memory limit MB in MS SQL const. Now, as for CPU, there are few more CPU tuning configurations that you should consider. This is once again one of some configuration where you would want system administrator to chime in to improve the. But configuring these options correctly helps you improve the throughput significantly. So you should look into this. The good thing is the three options highlighted in green, they are configured correctly when using tuned service. So if you use the tuned profile that I mentioned earlier, it will set these three options: the CPU frequency governor, energy perf bias, and min percentage correctly. There is one parameter, C states, that you have to configure manually yourself, and you should use your system administrator to make sure that you configure it to use only C1 state, so that if you configure all these parameters correctly, this would be equivalent to using high performance power profile on a Windows Server machine, which basically helps you make sure that your throughput does not decrease when your power state changes for the CPU. As for the network, you should reach out to your NIC vendor for guidance on how to get the highest throughput. There aren't really any common guidelines per se, but for example, if you are using NIC cards between the server and client, and which are high-end NIC cards and support, let's say, jumbo frames, and all the switches in between, switches and all the entire fiber, the network fiber supports the jumbo frames, then enabling jumbo frames might give you higher throughput. On the other hand, if your server and client support the jumbo frames, but the switches in between do not support the jumbo frames, enabling jumbo frames can cause fragmentation of the TCP frames, which can cause performance issues, in fact, significant performance issues. So you should be careful when you are configuring the network, and you should get your network administrator to chime in to make sure that you have configured it correctly in terms of both MTU, jumbo frame support, and anything else that can help you improve the throughput. Now, we have been talking about quite a few of this configuration, and we have talked about getting, choosing the right version of the SQL Server and Linux operating system in terms of the image. We have talked about the right VM size. We have talked about configuring the storage correctly, ensuring you get the appropriate Iops, etc., and configure it with appropriate striping, mount it using XFS file system, and configure SUA correctly. You get the and we have talked about the kernel tuning parameters. We have talked about the CPU tuning parameters. We have talked about a bunch of these parameters to see or to configure your SQL Server to perform as best as it can. Now, I just wanted to show that we obviously did some performance validation for SQL Server on Linux in Azure ecosystem. We chose actually one of the smaller VM sizes, which is 32 core and 256 GB memory VM size. We used 4 drives striped to host the data files and 2 drives striped to host the transaction log file. Used SQL Server 2019 CU6 and used a small database of 520 GB OLTP footprint. Now, and as you can imagine, just to make sure, this is not a performance benchmark. This is not. We were not trying to do official performance benchmark. At the same time, we used the same test configuration as TPCH, the Benchcraft test configuration, just to just to keep the things in appropriate context. And as you can see, if you configure your system correctly, you get very high throughput, very on a very well configured SQL Server on Linux ecosystem in Azure. I mean, these are extremely good and very high throughput numbers. And as you can see, they sustain over a significant period of time without any drop in performance. Few additional graphs that can show that through the time period, it can sustain anywhere between 35 to 40,000 read IOPS and 20,000 write IOPS concurrently. And Azure Blob Cache actually performs a pretty important part in helping the read IOPS throughput improvement. You should read about Azure Blob Cache, which it can help you improve performance significantly when you're using managed disks. And as you can see, we can significantly sustain I/O of 250 Mbps of read and 100 Mbps of write continuously. So as you can see, you can deploy SQL Server on Linux in Azure ecosystem quickly with the right kind of configuration. With help of appropriate parameters, you can configure the storage correctly as well. And then with help of appropriate kernel tuning and other storage tuning parameters, such as FUA and TuneD, you can get very, very high performing SQL Server in Azure very quickly. Now, I want to briefly talk about HADR for SQL Server on Linux. Now, in case of Windows, SQL Server relied on Windows Failover cluster as its clustering or high availability foundation on which SQL Server provided functionality such as failover clustering and always on availability group. In case of Linux, the equivalent of the Windows Failover cluster on Linux ecosystem is called Pacemaker and CoroSync. These are the services that work together to provide the functionality, high availability for Linux configurations. And SQL Server builds on top of the Pacemaker cluster to provide failover cluster instances, always on availability group. And in SQL Server 2019, we also introduced a functionality called read scale availability group, which can in fact work without any kind of clustering backbone whatsoever. Of course, the same these are the high availability options which are available with Pacemaker clustering, which is native to the operating system. At the same time, Linux being the open source operating system, it has additional clustering software available, which can also work with SQL Server to provide you with high availability solution. And we are going to talk about a couple of those later today. Now, let's talk a little bit about SQL Server availability group support in Azure VM. Now, this is actually not specific to SQL Server 2019. This is more about Pacemaker clusters in Azure. So traditionally, Windows failover clusters have been used to provide high availability to SQL Server failover clusters or always on availability group. Now, the equivalent of the Windows failover cluster in the Linux world is Pacemaker clusters. The Pacemaker clusters were not supported in Azure VM environments due to lack of Azure's fencing agent for Pacemaker clusters. And we'll talk a little bit more about it. So Microsoft team worked with the Red Hat and SUSE team, especially, to build Azure fencing agent and provide support for Pacemaker clusters in Azure VM environments. With this, now you can build SQL Server failover clusters or failover cluster instances or always on availability group environment over Linux Pacemaker clusters in Azure. So you get the same functionality that you had on premises on Azure as well. And let's talk a little bit more about that. So I'm not going to go into too much technical details about this diagram. This is a very simplified version of a diagram which defines the Linux Pacemaker cluster implementation. Basically, what we have are 3-node Linux Pacemaker cluster. The CoroSync service in the Linux Pacemaker cluster provides the quorum management on the OS side of things. In this case, we have installed SQL Server on each of these nodes to provide a replica environment. There is a Pacemaker service which sits on top of this Pacemaker cluster, which provides the resource management. Now, for example, for all of SQL Server AG resources or virtual IP resources, which are used to provide the AG endpoint functionality. The most critical part in this case, though, is the fencing agent. The Pacemaker service or the Pacemaker cluster uses the fencing agent to essentially reboot a node, a Linux node, if it identifies that node to be unclean in the state, or essentially if it identifies that a node is unresponsive, a Linux node is unresponsive, it uses the fencing agent to so-called fence the node, which basically reboots the node and gets it into a clean state. Now, the fencing agent requires more hardware-specific knowledge because it needs to know how to reboot a VM or a physical machine. Now, the challenge for Azure was that there was no fencing agent available which knew how to reboot the Azure VMs in a clean manner and a quick manner. So Microsoft worked with our Linux partners to build an Azure ARM fencing agent, so which now allows us to build the same kind of Pacemaker cluster. The overall functionality is exactly the same. What we now have is a new kind of fencing agent called Azure ARM fencing agent. So that allows us to build a fully supported Linux Pacemaker cluster in Azure, which provides the high availability, including the ability to reboot the node quickly if it finds the node to be unresponsive. And you can also have the AG cluster and the virtual IP resource, which provide the high availability to the AG availability group resource, as well as to availability group endpoint functionality as well. So let's just take a look at a demonstration of what a Linux Pacemaker cluster looks like and how to manage it. And I have also pasted links over here on how to configure the AG cluster, or how to configure the Pacemaker clusters with always-on availability group in Azure. These are very specific. These two tutorials are specific to Red Hat Enterprise Linux, and we have the tutorials for SUSE Enterprise Linux in process, which will be published in very near future. And we are also working with our Canonical partner to build Azure ARM fencing resource for Canonical as well. Now, let me show you an example of configuring high availability or availability group on Linux Pacemaker clusters in Azure. In this case, walking through the entire configuration steps would be unwieldy because it takes a while. So I'm just going to show you a fully prepared cluster. I'm going to show you a RHEL 8 cluster. In this case, I got 3 nodes of RHEL 8 or Red Hat Enterprise Linux 8, node 1, node 2, and node 3 in a same VNet. I have also created an Azure Load Balancer resource that I will talk about in a minute. And I have installed Pacemaker cluster on top of it, enabled Storage agent, and also enabled or created an availability group on top of it. So let's just take a look at it as to what it looks like in SSMS or Management Studio. So for example, I'm connected to my node 1, and let's see what the node 1 looks like. I've got one database which is in availability group. Let's see what the availability group status looks like. So it has one availability group, AG1, and it is currently in the secondary. The node 1 is currently a secondary replica. So let's take a look at what a node 2 looks like. And in this case, my node 2 is my primary replica. And node 1 and node 3 are my secondary replicas. I also have one database inside that and AG listener on top of it. The AG listener resource or AG listener definition looks something like this. It's basically a virtual IP address and a port number information that I have bounded. So let's see what that looks like in terms of the Pacemaker resources. So I'm connected to my node 1 in this case, and I'm trying to show this the resources on the node 1. So as we can see, my cluster name is AZ or Azure HA cluster. It has 3 nodes: node 1, node 2, and node 3. I have configured the StoneIt agent of type Azure ARM fencing, and this is what allows us to be able to support this Pacemaker cluster, RHEL Pacemaker clusters in Azure going forward. As you can see, I have also created an availability group resource, AG cluster, and it has one master replica, which is on node 2, and 2 secondary replicas on node 1 and node 3. I have also a virtual IP resource associated with it, which is the same as my AG endpoint resource. So let's see what my resource configuration looks like. As we can see, my virtual IP resource is the same as my availability group endpoint resource. I also took the liberty of defining an easy to remember AG endpoint or DNS entry and bound it to this AG endpoint IP address, and I've connected to that using the AG endpoint as well. As you can see, right now I'm already connected to my primary replica, which is on node 2. Now, just to see what the resource movement looks like, you might remember that when you are moving resources for SQL Server availability group on a Linux cluster, you do not move the resources using T-SQL. You must use resources using the Pacemaker command line. So in this case, this is the command line that I'm going to use. It's PCS resource move, and I'm asking the master resource for AG to be moved to node 1, and then do appropriate cleanup on top of it. So let's see, how that goes. So I'm asking the resource to move to node 1. So let's see if I can connect to node 1 and see if the resources are moving to this as. And as you can see, my node 1 has already become primary. So let's see if my AG endpoint functionality is also working fine. I'm connected to my AG endpoint, and let's see if I can refresh my availability group resource over here. Obviously, in the background, it has to reconnect. So it might take a few seconds for it to reconnect. On the Linux side, okay, and as you can see, it's already connected to my primary replica, where node 1 is my primary replica. Okay, so as you can see, we can easily move resources using PCS resource move command. Now let's try to see if we can test the fencing functionality. Now, fencing functionality is what's newly available. We worked with the Red Hat team to create Azure ARM-based fencing agent, and this is what gives the StoneIt agent or Pacemaker cluster the information about what type of resources these nodes represent, the node 1, node 2, and node 3, that they are Azure VM, and how to reboot this VM so that they can be brought into clean status according to Pacemaker cluster. That's how Pacemaker cluster understands and manages the resources if it deems any of the resources to be dirty. So now we know that node 1 is my master rep, and node 2 and node 3 are my secondary replicas. Just to see test what it looks like, let me just fence my node 1. And essentially, when I'm saying I'm fencing my node 1, this is essentially a test command. This is telling Pacemaker cluster to assume that node 1 is not clean. Now, since I'm executing it from node 1, what Pacemaker cluster will do is essentially it will reboot node 1. It will assume node 1 to be unhealthy, and it will essentially reboot node 1. So I'm moving to node 2 in this case and executing the status to see what the current status looks like. And as we can see, it's saying that it's promoting node 2 because it has already stopped node 1, and it is keeping node 3 as my secondary replica. So it takes a few seconds for it to promote the replica. And as you can see, it says it has already started the resources on node 2 as its primary replica. So now let's see if I'm connected to my AG endpoint, and let me see if I can refresh my resources and get the updated status. And in this case, once again, I can see that my node 1 is unclean and it is in rebooting state, so it shows as disconnected. Node 2 has already become my primary replica, while node 3 is my secondary replica. So now, with new Pacemaker or Stony agent being available for Pacemaker clusters for Linux VMs in Azure, you can create high availability based configuration, availability group environments for SQL Server high availability in Azure as well. And what I just showed you is a Pacemaker cluster, a 3-node Pacemaker cluster using Red Hat Enterprise Linux. But SUSE Enterprise Linux also supports Pacemaker clusters with appropriate Stony sensing agent. For example, this is my second cluster that I have created. It is based on SUSE Enterprise Linux, and it's currently connected to my primary replica, which is on node 1. So if I go ahead and connect to this node and find the server name, it says my server name is SLN1 or / node 1. And if I see my version name, it should give me SQL Server 2019, which is on SUSE Enterprise Linux. So as you can see, it is saying that it is SQL Server 2019 on SUSE Enterprise Linux. So as you can see, you can create Pacemaker clusters with full high availability and fencing functionality, and you can create SQL Server high availability configurations as in availability groups on top of this Pacemaker clusters in Azure. How can we monitor or configure the Pacemaker cluster itself? And now this is not really necessarily a SQL Server topic. What I can say is that most of this Linux distribution tend to have some sort of a UI support for managing and monitoring Pacemaker clusters. For example, in case of Red Hat Enterprise Pacemaker clusters, there is high availability management, what's also called PCS UI, and you can simply connect to this using your HA username and password, and then it allows you to understand what's going on in terms of the resources, the nodes, and it allows you to do the most of the configuration as well. For example, in this case, it shows me what's running on each individual node. It shows me what resources I have available and the attribute of each of the resources. And it allows me to do the fancy configuration as well. Now, just like Red Hat has Pacemaker, the UI Pacemaker configuration and monitoring tool in PCS UI, SUSE team also has something similar. It's called SUSE Hawk, and that provides very similar functionality as well. As you can see, I'm logged into the Pacemaker cluster for SUSE Pacemaker cluster that I had shown earlier here. This is my Pacemaker cluster on SUSE Linux, and I have one availability group with multiple replica on top of it, and the UI over here allows me to see the resources, which is my primary replica. It shows me, it's a pretty decent dashboard, which allows me to monitor the configuration and, do appropriate editing of the configuration constraints and fencing, etc. So if you explore a little bit about Pacemaker UI support for most of this Linux distribution, you'll find that you have some level of support which will allow you to be very productive very quickly for managing your Pacemaker clusters. Now let's quickly go over the steps required to configure Pacemaker cluster and SQL high availability on both RHEL and /VMs in Azure. Now, basically, I have sort of divided all of this into 9 different distinct tabs. And at the first glance, it may look a little daunting, but at the same time, what we have to remember is most of these steps are actually one-time steps, and you do not need to repeat them. I also color-coded steps a little bit in terms of the gold steps are typically configured by system administrators, while the blue steps tend to be configured by database administrators in most cases. So let's just briefly talk through them. The first steps are typically creating appropriate resources, which means creating resource group, availability set, virtual machines, and configuring high availability and Pacemaker cluster between all the necessary VMs. Then the next step is typically configuring the StoneIt device for fencing, which is what we talked about earlier, that we need to configure a StoneIt device for fencing to make to get Pacemaker cluster in a supported state. And all of this should ideally be configured by a system administrator. The next steps are typically the installation of SQL Server tools and the HA configuration agent, including configuring the necessary availability group endpoints for communication. And then after which the steps are basically configuration of SQL Server availability group and necessary resources in the Pacemaker cluster. As I said, it might appear daunting at first, but to be honest, up to this point are essentially all the basically one-time steps. All these steps would be essentially one-time steps, and the steps configured over here are what you do for each availability group when you decide to configure them. We have already documented our instruction set on how to configure a Pacemaker cluster and availability group on Red Hat Enterprise Linux. The detailed instruction for SUSE Enterprise Linux are to be published soon. They are currently being audited and reviewed. And we are working with Canonical to bring Pacemaker cluster support for Azure VMs, including the fencing support. And I have pasted a link over here. And soon enough, the Pacemaker clusters will be supported on Ubuntu distribution on Azure as well. Okay, so until now, we have talked about Pacemaker clusters as a clustering solution on Linux as a platform, which supports SQL Server availability groups and Failover cluster instances on Linux platform, and always an availability group on Azure as a platform. Now, the one thing which is very interesting is that Linux being open source platform, it has quite a few alternatives for the clustering technology, and you're not limited to the Pacemaker clustering technology technology per se. Now, one of the, I just want to mention a couple of different other clustering softwares which can show you alternative, although I'm pretty sure there are additional alternatives available in the wild. The first alternative, the clustering alternative that I want to mention, which is available on Linux as a platform for SQL Server, is called DX Enterprise by Ui Software. It is basically an alternative to Windows Failover cluster or a Pacemaker. This particular piece of software, the DX Enterprise, actually allows you to create clusters across Windows and Linux as a platform, as well as on containers as well. It enables you cross-platform and cross-distribution clusters, and it also enables you to create Azure AG replica benefit, because you can have your primary replicas on premises and secondary replicas on Azure, or vice versa, if you want to create some sort of a HADR scenario, a geographically distributed HADR scenario. Of course, this software also provides failover cluster instances as well. And the DX Enterprise software is a pretty good alternative for you to consider if you are, especially if you're choosing Linux as a platform, considering the kind of scenarios it can enable you with Windows and containers as well. So for this demonstration, I am going to use three VMs. This is my Windows VM, Windows 10 VM, which also has a SQL Server installed on it. I also have two other Linux VMs. This one is a Ubuntu VM, which is my Node 1, and this one is my Red Hat VM, which is Node 2. And I have already created a DHY cluster on top of it, to save some time in the demonstration, although it took me no more than 15 minutes to create the entire cluster across all three different nodes. So let's see what that looks like. When I look at it from the DX admin interface. The DX Enterprise software also comes with this DX admin UI interface, which is very helpful in creating and managing your DHY clusters. So in this case, first let's take a look at the cluster itself. The DHY cluster in this case has three nodes. One is the Windows node. Let's see the information there. So this is my first node, which is Windows 10 node. My second node of the DHY cluster is okay. It's a Ubuntu VM, Ubuntu 18.04 VM, which is part of my DHY cluster. And third node of my DHY cluster in this case is a Red Hat Enterprise Linux VM, as you can see. Now, from the flow perspective, the next step, once the DHY cluster is configured, the next step to configure is obviously to configure it from the SQL Server perspective. And from that perspective, the next step, what you do is create a vhost, which is an equivalent of virtual server for failover cluster instances, or always on availability group endpoint in case of AG scenario. I already created one of these AGs, so I'll just show you that first, and then I'll walk you through how to create one. So in this case, as you can see, I got a two-node cluster, the AG. One is a Ubuntu node. Second is the first node is the Ubuntu node. The second node is the RHEL node. I have created an AG on top of it, which basically is, this UI shows me the configuration of AG. it shows that my primary node is currently Ubuntu node, and secondary is the Red Hat node, and my EG configuration is a synchronous commit configuration. The seeding mode is automatic, and current situation is connected, as well as it tells me the actual database name and the current state of the database. It's a pretty nice UI from the management and monitoring perspective. So from the SQL Server side, if you wanted to see this, it looks like just any other availability group in this case. So as we know, in this case, the primary node was on, let's say, the the rel scenario. So we'll just, or rather the rel node. Actually, it's on Ubuntu node. So we'll just go with that and see. It says, now my primary replica is my Ubuntu replica, and my secondary replica is the Red Hat replica. The availability database is AdventureWorks 2017, and the listener is also created, and the listener the configuration is also what we already saw earlier in the DX admin interface. And as you can see, it's very, very simple to create and manage availability groups with DX admin interface. Now, let's say right now my primary replica is on Ubuntu, right? So what if I wanted to initiate a failover? And the DX admin UI interface also provides me capability to do that. I can simply choose the node that I want to make primary and simply say start hosting on that node. And the UI interface has enough intelligence to understand how to go about doing that. And as you can see, now it says that my primary node is now the Red Hat node, and secondary node is the Ubuntu node. So let's see, if the failover has occurred properly on the SQL Server side. And as you can see, if I refresh over here, now it says my AG is AG1 is secondary, and my the Red Hat node, which was secondary earlier, is now my primary replica. Primary replica. So this basically enables the DX admin UI interface enables you to create and manage the availability groups or failover cluster instances very easily for a DH2I cluster. Now that I have talked about SQL Server deployment, performance tuning, and high availability, I'm going to introduce my colleague Amit Khandelwal to talk about the security configuration or Active Directory configuration with AD-Util.
Hi everybody, my name is Amit Khandelwal. I'm a Senior Program Manager with Microsoft working on SQL Server on Linux and SQL Server on containers. Today I'm going to show you a quick demo of AD-Util and how you can use this utility to configure Active Directory authentication for your SQL Server in Linux as well as SQL Server in containers. This demo is going to be only specific to SQL Server in Linux. And to get started with, as you know, AD-Util is a CLI-based utility that's been created to make your experience seamless when configuring Active Directory authentication for SQL Server in Linux. And using AD-Util, you can manage both Samba and Windows domain. So you know what? Let's go ahead and jump into the demo and see how it all comes together. So I'm going to go ahead and switch to my environment. This is a rel environment that I'm running, which runs a rel 8 version. And what I'm going to do here is I'm going to first create an Active Directory user. Then I'm going to create an SPN. And then I'm going to bind it all together using a key tab, which binds the SPNs with the user. And then configure SQL Server using the MS SQL config option to actually use the key tab and the user that we just created. And this way, I'm going to enable Active Directory authentication, all of this from my single window here, which is running, which I'm running right now on a rel machine. So let's get started. To make things easier, I've got all the commands copied here. So I'm just going to go ahead and start running these commands one at a time. I hope you're able to see my screen and the font is quite visible. So I'm going to first go ahead and create a user. As you can see, the name of the user is SQL Pass user, and I'm going to give the specific location in terms of distinguished name, what it is, what is the OU and the domain that I'm going to create in. And of course, you should not provide the password in the plain text. This is the wrong way of doing it. You can use ADUtil and provide the passwords in the in interactive mode. To save time, I've just created the password here, typed in the password directly into this. So once I go ahead and run this command, I'm not going to run it right away because I already created the user to save some time. After this user has been created, all you've got to do is create the SPN. And to create the SPN, as you can see, you have to use the fully qualified domain name of the host and the port number that you need to provide with the user that you're going to register these SPNs against. Once you hit enter, you should probably see the SPNs getting created. To see the SPNs, you can use a command like this. And as you can see, all of these commands I can run from ADUtil and pretty much manage my Active Directory objects. Once I've looked at the SPNs, now it's time to create the key tab. And to create the key tab, I'm just going to copy this command here, run it right now. Once I run the key tab command, you'll see it'll ask me the encryption types that I want to use. I can use one or more. In this case, I'm going to show you how you can use two encryptions together with a comma separated values. And once I use AES 256, and the second one I'm going to use is ARC4 HMAC. Again, ARC4 HMAC is not recommended for production environments because this is a pretty old encryption type. So once I go ahead and click on that, the next thing is I need to again create a key tab entry for the user. And that is where this command helps me. Again, using the ADUtil command, I'm creating the key tab entry or appending the entry for the user. And I will use the same encryption types. Once I do that, my key tab file is created. Now I just need to ensure that the right permissions are given and it's owned by MSSQL user. Once I do that and ensure the permissions are rightly set, all I have to now do is configure the MSSQL config files using the two commands which I just pasted. And then I can just go ahead and restart the SQL Server service to ensure that it picks up the key tab. And once I do a restart, I can just quickly check the status to confirm SQL Server service is started. Once it has started, I can go here, connect to the SQL Server using SA account first. So when I use the SA account create, I will go ahead and create the login. Once the login is created, I can simply go ahead and then test my Windows authentication with this login that I just created. And there you go. With 6 steps of ADUtil, I was able to configure Active Directory without switching between Windows and different operating systems. So there it is. I'm hopeful that you start using it, and thank you for your time. Have a good one.
Okay, so today we have talked about SQL Server on Linux, and as you can see, it's a high performing database engine available on Linux ecosystem today. It includes advanced OLTP functionality with advanced analytics engine and the data warehousing functionality, which includes the heterogeneous data access with Polybase. It has the enterprise grade security features and enterprise grade and industry leading high availability features in terms of the always on availability group. We have also talked about how you can deploy SQL Server on Linux in Azure ecosystem efficiently using the Azure Marketplace images. We have also talked about how you can configure and tune your SQL Server on Linux in Azure system correctly to provide you the high performance and high throughput configuration. And we have also talked about the high availability scenarios available on Azure platform so that you can deploy SQL Server on Linux in Azure ecosystem with the kind of high availability requirements with appropriate SLAs that you may need and ensure that you are meeting all the enterprise goals that you have in terms of the SLA, SLO, and RTO. So with all of this, all I can say is that SQL Server on Linux ecosystem in Azure is absolutely fantastic alternative if you are considering the SQL Server on Linux, and you should never think twice about deploying it in Azure platform today. And with that, I just want to say thank you very much for your time. We really appreciate this. Once again, my name is Tejas. I'm Principal Program Manager for SQL Server Product Group.